Hey everyone, my name is Ajay. This is our part 5 of SD-WAN series. And in this section, we are going to continue to discuss the SD-WAN features. Application Aware Routing AR. This is another SD-WAN feature, and we are going to discuss in detail how it works. So in a traditional networking, doing the application-based routing, it is almost impossible. SD-WAN does help routing the application here. So let's assume I have a branch office and this is my data center and I have multiple links. This is my MPLS link, this is my broadband link, and I might have LTE or 4G connections. From branch to data center, I might be running multiple applications. I might be running the voice over IP. I might be running some sort of the FTP, and there can be data replication as well. Here I need to decide what is going to be my preferred way. So let's assume if it is a VoIP traffic, then definitely I want to give some sort of the preference, and my all VoIP traffic should travel over the MPLS. My replication traffic, I might give a preference of the broadband, and rest of the traffic I can use this LT connection as a backup, or I can say this is a particular application and it should go over the LT connection. What I need to do here to make it work, probably I need to write a policy, and the policy will look like this. This is my application X, and it must have latency less than 110 ms. Packet loss should be 3%, and the jitter should be less than 15 ms. My vmanage, it keeps track for all the paths. It knows how is the performance for all these paths. Based on that, it is going to decide. So for let's assume this is my MPLS, and I get 100 ms latency with jitter of 10 ms, and the packet loss is 1%. And this is the real-time values. They can fluctuate or change as well. Over the broadband, I get 100 ms, 12 ms jitter, packet loss is 2%. On my LT connection, the latency is 150 ms, jitter is 5 ms, and packet loss is 5%. So based on the policy, what I have decided, if this is my application and this is the criteria it should fill, then it is only going to qualify these two links because it matches a latency which is less than 110 ms, and we can see it is 100, 100, both the links. Packet loss should be less than 3%. That is exactly what we see. And the jitter should be less than 15 ms. Only these two links qualify for this particular traffic. Let's discuss about the RTT, which is basically the round trip time. So I can say a small packet that will be sent to a specific computer. So in this case, this is a client and it might be sitting a couple of miles from the servers. This media can be anything. You can be on the satellite link, you can be on the LAN side, or maybe you're using the dark fiber. So it depends what is the media and what is the latency you are going to get. So in this case, this media provides us the latency of 100 ms, which is one way, and another way you are going to get the same latency, which is 100 ms. So technically we can say I'm sending a small packet to the destination, and once I receive the acknowledgement from the destination to our source, the time period between these two packets is something which we call the RTT. So on my screen, we can see I have a client, I have a server, I'm running in some sort of the web application on the host B. And this is the SYN-SYNAC ACK when you complete the three-way handshake. So SYN goes from client to server, SYNAC comes from server to client, and then the final ACK goes from client to the server. Let's talk about TCP window size. TCP window size, it plays a very critical role when we talk about the total throughput which we are going to get between two WAN devices. It can be SD-WAN, it can be the WAN optimizer. The official definition of the window size is the number of octet that can be transmitted without receiving an acknowledgement from the other side. The larger the window size is going to be, higher the throughput you are going to get. So in this example, you can see I have a client, I have a server, and my window size is set to 4. It simply means I can send 4 packets of 1460, which is our MSS, and then this host B is going to send an acknowledgement. Let's talk about the window size calculation. I have a host A, which is a client. I have a host B where I'm running the FTP server, and I have a gig link, which is 1 gig link between these host and host B with the latency of 30 ms. My MSS here is going to be 1460. So if I take out the value of TCP header and IP header, then 1500 minus 40, it becomes 1460. So I can place maximum segment size of 1460 on the wire. Now let's discuss about a standard window size from the Windows machine. So standard TCP window size from Windows machine is going to be 64 KB. That is standard if you use all the 16 bits. Let's convert into the bits. 64 KB means 65538 bytes into 8. That gives us the bits. So it's a 524288. My latency is always measured in milliseconds. So I'm going to convert into a second. So it is going to be 0.03 seconds. Now let's talk about the throughput. It is going to be bandwidth bits divided by seconds. It means 17476266 bits per second is going to be the maximum throughput. That means if I'm doing a file transfer, it cannot exceed or go beyond 17.4 Mbps. You might hear a complaint from the customers, though we have a 1 gig link, but I'm not able to utilize it fully. And my FTP download speed never crosses 17.4 Mbps. That is true. How we can utilize it? That's the question. So technically, bandwidth delay product, it gives you the formula. This is my bits per second rate, which comes from the 1 gig link. Then I have a delay of 0.030 seconds. That gives me this much of bits. If I divide by 8, that gives me 3750000 bytes. And if I convert into the kilobytes, it is going to be 3750 KB. To fill this 1 gig link pipe quickly to utilize all the bandwidths, my window size is supposed to be 3750. How much we have here? Only 64. So these SD-WAN equipments and the WAN optimizer, they come with the higher buffer where this window size can be increased. And there was some enhancement in RFC 1323 that gives you an option to do the TCP window scaling, which allow us to raise the maximum receiver window from 65535 bytes to 1 gigabyte. All these TCP enhancements to get the better throughput from the WAN links basically. So if you read the RFC 793, you can see this is my window size. By default, it comes with 16 bits. So 2 to the power 16, it gives you a value of 65536. That's the default window, max window with unmodified TCP stack we can get. The modification we talked about having the window scaling. You can read this RFC, and it gives you a flexibility basically to add more bits. So this window size can be increased. If you read it, you will come to know there is something called the shift count, and the shift count is limited to 14. So my calculation of 1 gig comes from there. So by default, I have a window size of 64 KB, and if we calculate all the shift values, it is 2 to the power 14. That gives me a max buffer size of 1 gig. You can also enable the TCP optimization on VH device. However, TCP optimization are available on VH 1000, 2000 and 5000 hardware routers. So from host to SD-WAN connection, that's my regular TCP connection. From this host to SD-WAN, there is also going to be my TCP regular connection. However, between these two SD-WAN devices, I'm going to have the optimized TCP connection with higher buffer. How do we enable optimization on the VH? This is a command. You can go to refer to the configuration guide for more information. As we already discussed, TCP optimization are available on the VH 1K, 2K, and 5K hardware. There are a lot of algorithm which these equipments uses in the backend to do the congestion control. So you can see on my screen, these algorithm can be Reno, Vegas, Cubic, and you have a VBR. Then you have Quick also. That's the latest one. And all these techniques basically gives you a better congestion control mechanism and a better throughput over the WAN. So Viptela SD-WAN is based on the VBR, and ISR series of SD-WAN is based on the Quick. A common misconception persists that SD-WAN reduces or eliminates the need for the WAN optimization techniques. In reality, SD-WAN and the WAN optimizer, they solves the fundamentally different problems, and they are complementary to each other. Thank you for watching. I will see you in the next video.